We've learned about the box method and how it takes advantage of the distributive property of multiplication over addition to break up multi-digit multiplication problems, but we also saw how it can become unwieldy with larger numbers. To deal with this, we used the standard algorithm for multiplication. I will be referring back to the examples from the box method video to talk about why it works, so I do recommend that you've watched that first to fully understand the algorithm. However, you can learn to use the algorithm without understanding the box method first. We'll begin by using the standard algorithm to find 13 times 2. To start the standard algorithm, we write the multiplication problem the way we would if we were doing addition, except we write the multiplication operator instead. Now we begin with the digit in the ones place in the bottom number, which is 2. We multiply it by the digit in the ones place in the top number, which is 3. 2 times 3 equals 6, so we write a 6 below the line. Next, we multiply the same digit in the bottom number, 2, by the next highest place value in the top number, which is the 1 in the tens place. 2 times 1 is 2, so we write that in front of the 6. We've now multiplied each number on top by each number on bottom, and the answer is 26. We talked in the box method video about 13 times 2 being the same as the quantity 10 plus 3 times 2, which is the same as 10 times 2 plus 3 times 2. In the standard algorithm, we multiplied 3 times 2, which equals 6, first, and then 10 times 2, which equals 20, and we essentially added them together when we wrote the 2 in the tens place next to the 6 in the ones place. Let's look at the first example we used for the box method, 28 times 3. Again, we write the multiplication problem in 2 rows with the multiplication operator. I am going to do this a little bit wrong the first time because what I'm going to do is not the standard algorithm, but my hope is that it will make the connections clear to you when I do it the second time using the standard algorithm. We begin our multiplication with the digit in the ones place in the bottom number, 3. We multiply it by the digit in the ones place in the top number, 8. 3 times 8 equals 24. And this is where I will do it a little wrong. I'm going to write the number 24 below the line. Next, I need to multiply the digit I'm working with, this 3 in the bottom number, by the digit in the tens place of the top number, which is 2. I know that 3 times 2 is 6, but remember that this 2 is really a 20. I'm multiplying 3 by 20, which equals 60. So what I write below the 24 is the number 60, being careful to line up my place values. Now I add the numbers below the line. 24 plus 60 equals 84. This is exactly how we added numbers in the box method, and it gives us the same answer. Are you with me so far? If not, watch this chapter again. If you have watched it twice and you're still unsure about something, ask me for additional help. All right, we're ready to redo that problem, but this time we're going to completely use the standard algorithm. We go back to 28 times 3 written in 2 rows with the multiplication operator. We start with multiplying the digit in the ones place in the bottom number, 3, and we multiply it by the digit in the ones place in the top number, 8. 3 times 8 equals 24. We know that the 4 in 24 goes in the ones place, so we write the 4 below the line. But we also know we're going to need to add the 2 in the tens place to whatever we get in the tens place when we multiply the 3 by this 2. In the standard algorithm, we write our carried tens above the tens place of the top number. In this case, we are carrying 2 groups of 10, so we write a little 2. Now we multiply our 3 here by the digit in the tens place of the top number, which is 2. 3 times 2 equals 6, but we really did 3 times 20, which is 60. But wait, we have these additional groups of 10 to add to this number, so 60 plus 20 equals 80. We know we need to add 8 groups of 10 to the number below the line, so we write an 8 in the tens place. We have finished the standard algorithm, and our answer is 84, just as it was before. Let's try the next one from our box method video, 73 times 4, which is similar to the one we just completed. First, write the multiplication problem in the form we used for the standard algorithm. That's in 2 rows with the multiplication operator. The first number we work with is the ones place of the bottom number, 4, and we multiply it first by the ones place of the top number, 3. 3 times 4 equals 12. We write the 2 from the ones place below the line and carry one group of 10 above the tens place of the top number. We're still working with this 4, and we multiply it by the tens place of the top number, 7. 7 times 4 equals 28, and we have carried 1 to add to this. 28 plus 1 equals 29. Again, recall that we really just multiplied 70 by 4 and added a carried group of 10. So this 29 is actually 290, or 200 plus 90. We know that our tens place below the line is 9 because the tens place in 290 is 9. So we write that in. We're left with 200, which we could carry as two groups of 100. But because there is no 100s place to multiply, we know that our two groups of 100 is not going to change. We write the 2 in the 100s place below the line. Our answer to 73 times 4 is 292, just as it was with the box method. Let's try a new example, 483 times 9. We start by writing the problem in standard algorithm form, and then we work with the ones place of the bottom number and multiply it by each number in the top number, beginning with the ones place. 9 times 3 is 27. We write the 7 in the ones place and carry two groups of 10 above the tens place of the top number. Next, we multiply the number we're working with, 9, by the tens place of the top number, 8. 9 times 8 equals 72, and we have carried two groups to add. 72 plus 2 equals 74. We write our 4 in the next place below the line and carry our 7. Next, we multiply our working digit, this 9, by the next place value in the top number, the 4 in the 100s place. 9 times 4 equals 36, and we have 7 carried groups. 36 plus 7 equals 43, so we write the 3 in the next place below the line. We have 4 groups to carry, but we have nowhere to carry them, so we just write them below the line. The standard algorithm has helped us calculate that 483 times 9 equals 4,347. Here are a few problems that you can try on your own. Pause the video on each one and work it out, then resume the video to see if you have the correct answer. You're doing a great job. Remember, if you have any questions, ask me for more help. In the next video, we'll work on using the standard algorithm to multiply by two-digit numbers.